Alright, this video is for Mat 200 for your practice test and your final. The answers should be given on the back of your printout, so hopefully you checked yourself as you did it. I'll just go over the questions in case you had questions on where an answer came from. Alright, if you feel like I'm going too fast, just remember you can always pause and get yourself caught up. If you still have questions over something, please feel free to email me. All right, number 1, x over 6, x to the 6th and x over x to the 2nd, all to the negative 3 power. So first thing I want to do is kind of write out what that means. So that means everybody's getting the negative 3 exponent. So the rules when you raise a power to a power is to multiply your exponents. And then another thing to remember is that you cannot have negative exponents. It's kind of like a math rule, like not simplifying something. It's just bad. To put it in the opposite place to make it positive. And then the rules for division is to subtract. So we're doing 6 minus 18, which is negative 12. And then we want it to be positive, so we put it at the bottom. And because there was nothing at the top, that's where the 1 came from. Sorry, looking for my answer key. I don't know where it went. Alright, number 2. So everything's being raised to the 2nd power on the top. So 5 squared is 25. X to the 3rd squared is multiplying them. Bottom didn't have anything done. We can go a step further because we have x's in both spots, so we want to subtract. That's negative 4. And then the 25 stays at top because it does not have a negative exponent attached to it, but the x does, so we're bringing that down. Right, number 3. This whole polynomial is being squared. So if you remember, that means you're just going to multiply it together. Do not multiply this or square this and then square this and put it together when it is more than one term. That doesn't work. So you're just foiling. So 4x squared times 4x squared is 16x4. 4x squared times negative 2 is negative 8x squared. Negative 2 times 4x squared is negative 8x squared. Negative 2 times negative 2 is positive 4. And we can clean this up a little bit, and we can make those insides terms go together. Oh, there they are. Right, number 4. We are simply adding together the 2 polynomial terms. So we're putting things together that are exactly the same. So we have this. So 16 take away 12. That is 4. Ending stays the same. So that's taken care of. This is x squared. This is x squared. So we have negative 1 plus 3. So that's a positive 2x squared. And then this matches this. So we have 3 and 2, which is 5. So don't add your exponents together when you're adding or subtracting. The only time the exponents change is when you're multiplying or dividing. Alright, number 5. When you're subtracting, you got to remember that everybody in here gets the opposite sign. So when I do this, I just get rid of the parentheses. But do that means that everybody gets a negative sign. So if it was negative, it becomes positive. If it's positive, it becomes negative. So I just change the signs. And we'll put together what goes together. 9b3 take away 8b3 is 1b3 or just b3. Go on. Negative 4b squared has nothing else to go with. 3b take away 6b is negative 3b. And 2 take away 4 is negative 2. Number 6 is just a FOIL problem. So x times x, x squared, x times negative 6 is negative 6x. 4 times x, 4 times negative 6. And then we simplify this, put together our middle terms. And if you FOIL, that will always happen, where your middle terms need to be combined. Unless it's a certain kind of polynomial, then it might cancel out. Right, long division. We have lots of room, so we'll go ahead and do that down here. So we want to set this up first. Now, don't forget that when you set these up, these need to go down in descending order. Since we don't have a y squared, I'm going to put a 0 in there. It has to be set up correctly, or when you actually do the division, it won't line up correctly. So if you are missing one of the descending numbers, just put a 0 in front of it. Right, so you're taking your first term into your first term. So 2y goes into 4y to the third 2 times 4 divided by 2, and then y3 divided by y is y squared. Multiply it by both of these, so this times this, this times this, so this times this is 4y cubed, take away 6y squared. If you did this correctly, you should have the same exact exponents lined up. Then we will subtract. When you subtract, you change the sign of both. This is gone. 6y squared, bring down our next one. Now you're doing your first term into your first term again. So 2 goes into 6, and if this is positive, this will be positive. If this is negative, this will be negative. 2 goes into 6 3 times, and y goes into y squared y time. Multiply, so 6y squared, take away 9y. 3 times this, 3 times this. Subtract is changing the signs of both. This is gone. Bring down. Now we're doing first term into first term again. So 2 goes into 12 6 times, y goes into y once. Multiply 6 times 2y, 6 times negative 3, subtract, we'll just change the signs of both. This is gone, and this is 23. Alright, so when you write your answer, this, what we just did at the top, is our quotient, and then our remainder gets written over the divisor, like such. I always like doing those, but I know everybody hates them. Once the light bulb goes off on those, then you'll enjoy them much more. Alright, number 8. Factor completely for 8 through 12. Alright, so first look to see if anything can come out at all, which nothing can. So now you're just going to say what goes into 6, multiplies into 6 as an equals 6, but those two factors add to give you 7. So the only thing I can think of is 6 and 1. So x goes in what you want to unsquare this, and then these are both positives. And if you have any doubts, you can always FOIL them and see if it works. So either direction you can write these, it doesn't matter. Alright, number 9. Nothing can come out of all of them, but anytime there's 4 terms, I can group them and then factor each group. So if I group this, I can take an x squared out of both of these. The parentheses is what's left. So if I take x squared out of x3, I'm left with x. If I take x squared divided by x squared, I'm left with 1. then I can take 1, so pretty much nothing, out of the second one, so it doesn't change. The goal is if this matches, then you've grouped correct. You can group it. So that's your first parenthesis. What's left over is your second parenthesis. And again, you can flip-flop the order. Right, number 9, nothing can come out of all. So since there's a coefficient here, we're going to multiply these two together, and we get negative 27. So we're trying to find factors that multiply to give you negative 27, add and give you 8. So first thing, I just start by listing off factors of 27, and I believe that's it. No matter what I do, I can add these, one being negative, one being positive, both being negative, so on and so forth. I will never get this positive 8. So this is a prime question. Means it cannot be factored. It is in its prime form. Right, number 11. First thing I want to do is see if I can take something out of all. So I look at the coefficients first, and 2 can come out of all of it. Well, let me not put that there yet. Let's start over. 2 can come out all of it. And then if I look at my variables, they all have at least 2 x's, so I can take that. You don't want to take any more than your smallest one. So when I divide 24x4 by 2x squared, I'm left with 12x squared. If I divide 10x cubed by 2x squared, I'm left with 5x. And if I divide 4x squared by 2x squared, I'm left with 2, period. Now we're going to see if we can factor this. So those two multiply together equals negative 24. I need 2 factors that add up to negative 24. Multiply at negative 24 and add up to 5. So the first thing that popped in my head was 8 and 3. So to make a negative 24 when we multiply, one of these has got to be negative. To figure out which one, this needs to be positive when we add them, so we need our bigger one to be a plus and our smaller one to be a minus. So what I do is, this guy's not being touched, I rewrite that middle term as in, I'm going to go the opposite direction, 3x plus 8x, and then minus 2 gets brought down. So this still means the same thing. These, when we combine them, still equal this. Then I can group it. And then out of this I can take negative 3x. That leaves 4x minus 1. Out of the second one I can take a positive 2. And when I do that, I'm left with 4x minus 1. Our whole goal was to have the same in the parentheses. So don't forget about this guy. I'm going to go ahead and put him out front so we don't forget him. But that is part of our answer. 2x squared. Then we have this in one parenthesis. And we have what's left in the other parenthesis. I'll show you this. I don't know why this says negative. That should be a positive. 3x plus 2. Sometimes I write things that my brain is thinking, or I won't say it, and then I'll do something completely different. Yeah, the math brain, it's amazing. Alright, number 12. This is a sum, or a difference of squares. This is a square, this is a square, so if you remember, you just do this. And then you put a plus and a minus in between them. And it doesn't matter what order you write them in. Alright, number 13. The solution is to 2x squared plus 7x equals 4r. So to be able to do this, we want to factor it. To be able to factor it, though, we want all our numbers on one side. So let's see if we can factor this. We need it to multiply together to equal negative 8. Add together, get positive 7. So of course I'm thinking 8 and 1. One of these has to be negative to make a negative 8. but we need it to be a positive 7, so this will be a plus, this will be a minus. So I'm going to rewrite my term. Then I can group it. I'm going to move over here. I could take a 2x out of the first term, and I'm left with x plus 4. I can take a negative 1 out of the second term, and I'm left with x plus 4. So I have 2x minus 1 and x plus 4. We want to set those to 0. So moving down here just to be able to solve this. So when I solve this one, I get x is a half, and when I solve this one, I get x is a negative 4. So our answer is a half and negative 4. Kind of running into our next problems. Sorry about that. Alright, number 14. That polynomial is undefined for what values? So that means that you're going to set your bottom to 0, because undefined means we have 0 in our denominator, which means it can't be done. So let's go ahead and factor this. So it needs to multiply together to give you negative 12, add together to give you negative 1, 4 and 3 pop in my head. This needs to be negative, this needs to be positive. So let's rewrite this. Let's do plus 3y minus 4y minus 2. Then I'm going to group it. And we're going to take 3y out of our first term and left with 2y plus 1. And we'll take away a negative 2 out of the second term, and I'm left with 2y plus 1. So we have 3y minus 2 and 2y plus 1. We want to set both of those to 0. And I'm left with 3y equals 2, y equals 2/3, 2y equals negative 1, y equals negative a half. So our two answers are 2/3 and negative a half. Right. Number 15. I think I'll go on another sheet. So it says for these questions we want to simplify. So a fraction in math is not simplified. So we need to get those fractions out. So we look at our denominators of wherever they are, and we find a common one. Well, this one's easier because they're both y's, so we're going to multiply everything by y. So x times y is xy. 2y times y is 2. If you need to see that, they cancel out. Then the bottom is xy times y is just x. And that's as far as this can go. You want to pay attention to factoring and so on and so forth, but this is not factorable, and we can't take this x out of here because these guys are connected. So if you took an x out of here, you'd have to take an x out of here, and he has no x to give, so this is as factored as it can get. Alright, number 6. We'll try to do this on the sheet. Alright, so it's a division problem, which means we're going to change the multiply and flip. We're going to factor everything to death, and then we're going to cross stuff out. So let me look at the first one. We have y3 plus y. We can take y out of there. So that one's factored. The bottom I can take y out of, and I'm left with y minus 1. Then I'm changing it to multiply, and then we're going to factor this. So what multiplies together to give you 1, adds together negative 2. So y, and 1, 1. We need both of them to be negative. A negative and negative make a positive, add together give you negative. Then the top I can take y squared out of both, and I'm left with y minus 1. So once you've factored everything, then just start crossing off. Those can be canceled. Those can be canceled. This can be canceled. And then don't forget, you cannot cancel this with this because these right now are married. So you have to do for one as you do the other, and we can't take a y squared out of here. So this is your final answer. Alright, number 17. Alright, number 17 is a multiplication problem, so it's very similar to what you just finished. On the previous question, we're just going to factor everything as much as we can. So my first one I'm going to take a 2 out of, and I'm left with 3x plus 1. The bottom one is a difference of squares, so we can do that. Top one, 1 minus x. Bottom one, take out x, we're left with 3x plus 1. Alright, so cross off our obvious stuff. Now these are opposites of each other, so if you take a negative 1 out of here, it'll flip the order. So negative 1 just means negative 2 times negative 1. I'm just bringing it out front. So once I do that, then they're good. Nothing else can go. Right, 18, to be able to add our terms together, we need this common denominator. So in this case it would be 26, so I want to times this one by 2. So I'm left with 14x plus 2 on x on the top, and then 26 is our new bottom. And this is 16x over 26. We can reduce this by dividing by 2. And our final answer is 8x over 13. Right, 19. We need a common denominator, so we're going to factor these out to see what they look like in their better forms. So we have x, x, 3, and 1. We have x, x, 3, and 1. And then this one will be negative, this will be positive. So our common denominator is x plus 1, x plus 3, and x minus 3. So everybody, everything you see needs to be there. Alright, so that's our new bottom. Now how we do our top is what it's missing. So the first one was missing our x minus 3, so we're timesing this by x minus 3. So I'm just going to put it here for now. And then the second one is missing the x plus 3. So now I just simplify by distributing. I'm going to leave the bottom in its form. And then we can combine some terms. So we have negative 2x minus 24 all over x plus 1, x plus 3, x minus 3. And if you want, you can factor that. Factoring you want to do if you think that it's going to help you cross out stuff. If I factor this out, I'm going to have a negative 2 on the outside and x minus 12, which doesn't help. So this answer or the factored version is fine. Alright, number 20, let's find our LCD. So this is our first term factored, and that's our second term, factored. So our LCD is y plus 1, y plus 4, and y plus 1. So since he has 2, we need 2. Alright, so this is our new top. Our new bottom looks like this. And then our first term is missing a y plus 4. Our second term is missing another y plus 1. Then we're going to FOIL it, or I'm sorry, distribute it. I'm just going to kind of shorten that. And then we'll combine like terms. We have y squared plus 8y plus 4, y plus 1 squared, y plus 4. So this one can't be factored any further. It's in its prime state, so there's no use in trying to go further. Right, number 21, we were doing expressions, which means there's no equal sign. When we turn it into an equation, then we're actually solving and given a value for x. So same type of thing, we need our LCD. This would be 3 and 2, positive, negative. So our LCD is x plus 3, x minus 2. So when you're going to multiply every term by this. So when you do that, like your first term gets multiplied by this, it cancels out the x plus 3 on the bottom, but we are left with an x minus 2. When we do the second one, the bottoms will cancel out and then we just leave the 20 on top. And your third one, we're left with 5 and x plus 3. Then I'm going to distribute. Combine like terms. Put my x's on one side and my numbers on the other. And I get 7. So that one came out nice and pretty. Alright, number 22. Factor first to find out what our LCD is. So our LCD is y minus 5, y plus 5. Every term gets multiplied by those. So when I multiply this term by it, the bottoms cancel out and leave just the top. When I do the second one, bottom cancels out and leaves this for our top. The last one leaves that. Distribute. Combine like terms. Put our y on the other side, put our 10 on the other side, and we're left with negative 3. So on the ones that say solve as an expression, well, you're not solving the expressions. You are just simplifying all these. But when it says solve, you should have an answer or two. Sometimes you have two answers. Alright, 23. A truck can travel 120 miles in the same time it takes a car to travel 180 miles. If the truck's rate is 20 miles per hour slower than the car's, find the average rate for each. Alright, so I always like to start by setting up the chart kind of like what they had on my math lab. So they always give you the distance and the rate, and you want the time, which is always the distance divided by rate. Alright, so it says a truck can go 120 miles, a car can go in 180, and it says that the truck is 20 miles slower. Well, the car we don't know, but we do know the truck is slower, 20 miles slower than whatever the car is. So if we just put these together, we get our two equations, and it says it does the same time. So if we set these up as an equation that are equal to each other, oops, this should be ax, sorry, cross multiply, get my calculator. this over. Alright, so I get X is 60. So X is the car. So the car can go 60 miles per hour. And the truck can go 60, take away 20. So the truck can go 40 miles per hour. Alright, 24. One pipe can fill a hot tub in 20 minutes. Second pipe can fill it in 30 minutes. If the hot tub is empty, how long will it take to fill both pipes? Alright, so in terms of hours, one pipe is 1/20th of an hour. The second pipe is 1/30th of an hour. And then our whole job is just an hour. Or one whole job. We could look at it this way. Alright, to be able to solve this, we want to get rid of our fractions. So we're multiplying by an LCD. So when I multiply this by 60, I'm left with 3. When I multiply this, I'm left with 2. And then don't forget your 1 gets multiplied. 5x equals 60. And x equals 12. And this is minutes. And last, the length of a rectangular garden is 6 feet longer than its width. If the area of the garden is 55 square feet, find its length and width. So if you remember, area is length times width. We want to write this in terms of x. So we have length and width that we have to define. Usually what they say last is your x. And then it says our length is 6 feet longer. So if we don't know what it is, we just know that it's 6 feet longer. Then we're going to plug this into here. So our area is 55. Our length is x plus 6. And our width is x. Distribute. Put everything on one side. And then factor. So we got 5 and 11, I believe. And this one needs to be positive, this one's a negative. We set both of these to 0. This we get 5, this we get negative 11. Well, there's no such thing as a negative side length. So one of our sides is 5. Since I defined it up here, I know that's my width. And they're telling you to find both. So the width is 5 feet. And then 6 more would be our length. If you have any questions, let me know.